Hi guys, welcome to another section of Learning with Prepclass. I am Tutor Chima. In today's section, we are going to be looking at past questions on Jamb chemistry for the year 2017. And we are going to be solving questions 11 to 15. This is so because in the previous section we solved questions 6 to 10. So today we'll be looking at questions 11 to 17. Alright guys, before we proceed, do not forget to subscribe to our YouTube channel, like our videos. If you look below there, you are going to see our comment section. I urge you to drop 1 or 2 questions on our comment section box. The question you want to drop can be on today's video, it can be on the previous videos I've done. Also, if you look there too, you are going to see a notification, an icon for notification. I'll join you to click and activate it. When you do so, you'll be the first to be notified whenever we have an educational content like this on our channel. You can also do well to share our videos so that it's going to reach as much viewers as possible. Now, having said that guys, we are going to go straight to the business of today. Question 11. When large hydrocarbon molecules are heated at high temperature in the presence of a catalyst to give smaller molecules, the process is known as. When large hydrocarbon molecules are heated at high temperature in the presence of catalysts to give smaller molecules, the process is known as. Is it disintegration? Is it polymerization? Is it cracking? Is it degrading? Now I said that in organic chemistry, cracking is the process whereby complex organic molecules such as kerogenes or long-chain hydrocarbons are broken down into simpler molecules such as light hydrocarbons in the presence of a catalyst. So in organic chemistry or in the petroleum industry, they can heat up a hydrocarbon with a catalyst at a high temperature to break it down into smaller hydrocarbons that can be used. For example, diesel can be cracked and broken down to give what? Petrol. So that process is known as what? Cracking. Sometimes they call it catalytic cracking because it takes the role of a catalyst to speed up the chemical what? Process. Are you following? So the process by a hydrocarbon is broken down into smaller forms at a high temperature in the presence of a catalyst is known as catalytic cracking. So such a process is known as what? Cracking. So our correct answer there is what? Cracking. 12. If concentrated sulfuric acid is added to sugar and warmed gently, the sugar change from white to brown and finally to black, finally to a black mass of carbon. In this reaction, concentrated sulfuric acid is acting as, is it a drying agent, is it an oxidizing agent, is it a dehydrating agent, is it a reducing agent? Now they are telling us that we added, they are telling us here that we added sulfuric acid, concentrated sulfuric acid to sugar, and after some time the sugar turned black. I've done that experiment before when I was in secondary school, way back many years ago. We added dark brown. 4 Qsts is like almost dark brown in color, or light brown. So we added dark, that's concentrated H2SO4 to sugar. When you do so, the sugar is going to turn black. If you get a piece of powdered wood or cotton wool, you add sulfuric acid to it. After some time, it turn brown, from brown to black. If you get a piece of paper, filter paper or so, add sulfuric acid to it. Before you to turn from brown to black. That black is completely carbon. This is so because the sulfuric acid removes what? Water from that what? Component. So I said the acid is acting as a dehydrating agent. This is because the acid removes water from sugar, converting it to a black mass of carbon. So that black substance you are seeing that is left behind is nothing but what? Carbon. And because of that, the sulfuric acid is acting as a dehydrating agent. 13. Smoke consists of Smoke consists of, is it solid particles dispersed in liquid? Is it solid or liquid particles dispersed in gas? Is it gas or liquid particles dispersed in liquid? Is it liquid particles dispersed in liquid? Now, look at what I said. Smoke is a collection of tiny unburnt particles, very small carbon particles, and tiny droplets of tar. That's what smoke contains. Tiny unburnt particles, very small or tiny carbon particles, and tiny droplets of tar. Smoke is a collection of tiny solid, liquid, and gas particles. So since smoke contains tiny solid, liquid, and gas particles, that means that smoke are solid or liquid particles dispersed in a gas medium. Are you following? So the correct answer is that smoke consists of solid or liquid particles dispersed in a gas medium. So your best choice there is option B. 14. In the electrolytic of dilute sulfuric acid using platinum electrodes, the products obtained at the anode and cathode are, this should be anode, not motor. There's a typo here, anode. The product obtained at the anode and cathode are anode, cathode. So, is it at the anode you get sulfur, cathode, hydrogen? Is it at the anode, hydrogen, cathode, oxygen? Is it at the anode, oxygen, and at the cathode, hydrogen? Is it at the anode, hydrogen, and at the cathode, sulfate? Let's see. So let's see. So I said that dilute sulfuric acid contains H2SO4, that's the sulfuric acid in water. That is the dilute sulfuric acid, H2SO4 in water. So now the H2SO4 will dissociate into hydrogen ion and tetrasulfate 6 ion or sulfate ion. The water will dissociate into what? Hydrogen ion and hydroxide ion. So the anions here are tetrasulfate 6 ion and hydroxide ion or hydroxyl ions, while the only cation here is what? Hydrogen ions. Okay. So at the anode, of course, the anions will drift to the anode. The cations will drift to the what? Cathode. That's how electrolysis happens. So at the anode, these two will drift to the anode, but this one will be discharged. So at the anode, OH minus will drift to the anode. That simply means that this one will be discharged, while this one will be left in solution. Why? Because this one is much more electronegative than this. So this one is less electronegative, so it's going to move to the what? Anode. So it will be discharged at the anode. So OH minus will give 4 electrons to the anode and be discharged as 4 OH. This 4 OH will not dissociate towards hydrogen and oxygen. So therefore, oxygen is liberated at the anode. So at the anode, what will be given off is 4 OH, but it's going to be given off in the form of oxygen gas. So oxygen gas will be liberated at the what? Anode. At the cathode, what happens? Hydrogen will drift to the cathode. At the cathode, the hydrogen ion, not hydrogen, the hydrogen ion will drift to the cathode. At the cathode is going to accept 1 electron from the cathode and become deposited as hydrogen atom. So hydrogen atoms that are being deposited will combine with hydrogen atom to give hydrogen molecule, which is hydrogen gas. Therefore, hydrogen is liberated at the cathode. So at the anode, oxygen gas is liberated. At the cathode, hydrogen gas is liberated. So the electrolysis of dilute H2SO4 gives what? Oxygen at the anode and hydrogen at the cathode. So the correct answer is at the anode, oxygen, at the cathode, hydrogen. 15. P plus Q give you a reversible reaction 3R plus S, delta H is negative. Which of the following will increase the yield of R? Which of the following will increase the yield of R? Using a large closed vessel, increasing the temperature, removing some S, adding a positive catalyst. Let's see. So now, I said that removing some S will shift the equilibrium position to the right, therefore favoring the forward reaction and increasing the yield of R. So what will favor the yield of R is for you to remove this S. As this reaction is going on to produce 3R and S, as you continue to remove S, more of this will be formed. Why? Because the equilibrium position will shift to this other side. Remember, this is a reversible reaction. Reversible reaction tells us that as the forward reaction is going, the backward reaction is also taking place. As these two are combining to give these two are combining to give these two back. But if you now remove one of the entity of the products, if you remove one of the entities of the product, it's going to cause this equilibrium position to shift to that side. That's what happens. So if you continue removing this, it will cause the equilibrium position to shift here, favoring the production of what 3R. So the answer is removing X will give us more production of what R. So your answer is removing some S. C. Alright guys, we've come to the end of today's section of Learning with Prep Class. We'll look at past questions on Jamb 2017 chemistry. We solved questions 11 to 15. If you look here, you will see a link. I urge you to type this link on your browser. When you do so, it's going to take you straight to our WhatsApp group. When you join us on WhatsApp, you'll be getting updates, you're getting infos on the latest content we have on our channels. So till you see my video again, I still remain Tutoshima. Bye.